The next type of concentration that we're going to look at is going to be molarity. So we'll have a solute and we'll have a solution. And in molarity, the units are a little different than what we've seen so far. This is a unit that chemists like because it's really good for counting. So we'll see that the units have to be moles over liters. And again, like we've been doing with the solution problems, we're going to look at two different types. One type of problem where we find molarity, and then another type of problem where we use the molarity. So let's do a very challenging problem here to start with, and then I'll leave the easy one for you to practice on. Also do all the problems in your book related to this. So calculate the molarity. Initially, I'm thinking, okay, that's moles over liter of a solution made from 12 grams NaCl in 500 mils of solution. So I can see I'm given a solute and a solution. The problem is it's in grams, which is not moles, and it's in mils, which is not liters. So I'm going to go ahead and convert those units, 12 grams of NaCl, use the molar mass to convert it to moles. That would be off of the periodic table, 58.44 grams per 1 mole. And when you do that calculation, you get 0.205 moles of NaCl, which is going to be a much better solute unit for us. Then I'm going to take this 500 mils, use your metric conversions, and go from milliliters to liters. It's 1,000 mils to 1 liter. And this gives you 0.5000 liters. So now I have my solute and I have my solution, and I can plug them into molarity. So molarity is going to be the solute moles over the solution liters, and that comes out to 0.410 molarity. So let me just emphasize for you here, I have solute that I converted to moles and then used here. Also, there's some solute in that molarity there. Here's my solution that I converted into liters, put it here. And so molarity actually has two different units kind of hidden in that one letter. So it really helps me a lot of times to think about molarity as moles over liter. And that'll be especially useful when I come over here to use molarity. So I'm going to keep this concept in my head that molarity has actually two units hidden in it. So let's read through this problem. How many liters of, so there's my how many, of a 1.5 molar glucose solution are needed to obtain 0.15 moles. So first off, kind of like with the percent problems, I want to rewrite this 1.5 molarity as more like a conversion factor. So that would be 1.5 moles of glucose per 1 liter of solution. And then I can use this 0.15 as my starting point. So 0.15 moles, that would be of the glucose. Here's a conversion to relate moles to liters, because I'm looking for liters ultimately. So my moles of glucose would be 1.5, using this conversion here, 1 liter, and that answer comes out to 0.10 liters. So to get this many moles, I would need that many liters. And so I went from solute, and I was able to convert my solute into solution, and there's my solution quantity. So I'll leave you a couple to practice here. Here's a finding molarity, and here's a using molarity. Just keep an eye on your units because molarity is always moles per liter.